Hello again. In this video we're doing differentiation from first principles. So that was that super long thing we did last year, and then you learned the shortcut and then you wondered why we learned it. And this is for learning intention 10. So I only want to do one example, and this has I've never seen this on a past exam, but it's in the study design. So we have to go through it, but I'm only going to do one example because it doesn't seem to be super important. So let's start with a function. F of x equals x squared plus 3x, and say I want to find its derivative, but I've never met the tips and tricks we use. So I'm going to write the derivative anyway, just so we know that we're going to get the right answer. But pretend we didn't know that we could just find the derivative like that. How would we find it? Well, we'll do it from first principles. And the formula is, you will need to know this formula. This is an incredibly important formula. It's f dash of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. So that is the definition of the derivative. The reason that's super important is because all those definition of the derivative, all those derivatives in the previous videos that looked kind of, I don't know, like they didn't make sense where they came from, they all come from here. You can derive every single derivative from the previous video by starting with this formula. Some of them you can do with just methods understanding. Some of them will require some specialist maths. Others will require university level maths. But it is important to know that they all come from here. So they might look kind of arbitrary, but this is where they come from. So let's find this derivative. Well, we've got to do a substitution. So the derivative equals the limit as h approaches 0 of f of x plus h. So here's f of x. We need to sub in x plus h all squared plus 3x plus h. Notice how x plus h is the argument, and it's getting subbed in to this function. So the x's of this function are replaced with x plus h. Minus, and do a big bracket here because it's a minus, and that minus is going to expand into everything. F of x, well, that's f of x. And that is all divided by h. Alright, we need to expand, so equals the limit as h approaches 0 of, that expands to, and you should know from your binomial theorem, x squared plus 2hx plus h squared plus 3x plus 3h minus x squared minus 3x, and that's all over h. Alright, now I've got to collect some like terms. Well, there's x squared, there's minus x squared, so they disappear. There's 3x, there's minus 3x, so they disappear. What have we got left? We've got 2hx, h squared, and 3h. Alright, let's cancel this down a bit. So we've got h squared plus 2hx plus 3h. Okay, and that's all over h. Alright, so the next bit, and we had a, I'm going to clear this in a moment, so if you want to get it down, pause it, but We had a different approach about how we did this part. Some people did it differently. I'd prefer you to do it the way I show you. And the reason is it shows you know what you're doing. So we're up to this part. Let me just write this out again. Limit as h approaches 0. That's f dash of x. So some people liked to cancel straight away. I need you to factorize first. You need to factorize the h first. So we're going to take out h plus 2x plus 3 on h. The reason you need to take the h out first is because when you cancel them, you need to show that you understand h doesn't equal 0. This is a very important step. When you cross these two out, you must write h does not equal 0, because you can't cancel them if h equals 0. You're basically showing you understand calculus here. Really important. And then they cancel, so we have the limit as h approaches 0, h plus 2x plus 3. Now you can substitute h in for 0. So we get 0 plus 2x plus 3, and that equals 2x plus 3. And that's our derivative. And if you want to do another example of this, you can make up your own function. You'll know the derivative, you'll know the answer, and then you can go through this process to make sure you've got it down and you've done it correctly. The place where a lot of people tend to make mistakes is down here. When you go from this line to this line, you're subbing in h equals 0. The limit is an operator. If I have the limit as h approaches 0 of h plus 1, the way I solve for limit is I substitute h in. So that becomes 0 plus 1 equals 1. So you're substituting the value for h in, and then you're solving. So that's a place to be careful. But if you have been, thank you for watching.